Today, guys, we will discuss Palo Alto Firewall management plane. What are the processes we are having in your management plane of your Palo Alto Firewall? How these processes connected, how they will communicate with each other, everything we will see in detail. So this is the glimpse of your Palo Alto Firewall management plane and data plane, how all these daemons are running into these planes and how basically they have connected with your system daemon. And here you will see management plane. These are the daemons which we have in your management plane. Now what are the job of these daemons? Everything we will see in detail. Okay, so I have taken the SHS access of my firewall here, and if you really wants to see what are the daemons we have in your Palo Alto firewall, so if you will run this command, so system software status, you will able to see all the daemons. We have your pen task daemon along with their process IDs, and state is running, right? So here we will able to see all the daemons like HSSD, H agent, F manager, ICAM manager, key manager, right? User ID, tunnel D, sysd agent, system D, right? So many daemons are there. So before going into these daemons, let me just explain you what kind of architecture we are having in your Palo Alto firewall. What are the different types of chips we are having in this Palo Alto firewall, and how they will basically communicate. Okay, so as you know, Palo Alto firewall have two things basically, or PAN OS basically, or Palo Alto, they have divided this PAN OS architecture into two planes. First plane is known as your data plane, and second plane is known as your management plane. Now in this data plane, it is further divided into one of the a small plane, we can say, that is known as control plane. Okay, so if I show you the architecture of one of the firewall, so if I'll go here, let me just open one of the Palo Alto firewall architecture. Yeah, this one looks good. So if you will see, this is the architecture of your Palo Alto 300 series box. In this box, you will see we have a dedicated management plane here. That plane, or this management plane, it is responsible for your configuration, your logging, and your reporting, right? And it is having a dedicated CPU core, dedicated RAM, and dedicated storage, along with one dedicated management port and one dedicated HA port. This HA port is known as HA1 port. And after that, we have a data plane. Now this data plane is further divided into three planes: signature matching, security processing, network processing. So I can say this particular processor is known as a network processor. Your security processor is your actual data plane CPU. This is your data plane CPU, and this security processor, he is responsible for processing the packet as per the packet flow of your Palo Alto firewall. And now we have a signature match processor. This processor is responsible for two things only: app ID and content ID. These are the jobs of this particular plane, and you will see your data plane is further divided into these three planes, right? And each planes, they are having their dedicated RAM and dedicated CPUs are there inside these planes, right? So they have a dedicated RAM and they have a dedicated CPUs. And this is the architecture of PA 300 series box. Now, if I'll show you the architecture of 500 series box, or let me just go down, because I have that diagram here. So if I'll explain with the diagram, you will understand easily. So let me just go down. So let me just open this one. Okay, so if you will see this particular diagram, guys, This is the diagram of your Palo Alto 500 series box. And if you will see this particular box, and instead of one CPU, it is having 3 data plane CPUs, DP0, DP1, and DP2. This is your data plane. Tiger, this is your network processor. And we have a Marvel chip, and we have a Petra chip. This is your Tiger chip, and these data plane CPU, these chip is known as a Octeon chip. So we have here 3 Octeon chip. And after that, we have a signature match processor 1 and signature match processor 2. And this is the diagram of 5060 box. This is the 5000 series Palo Alto box. And it is having 2 chip. This is your signature match processor who is having the chip name is known as a Jaguar chip. This is a FPGA, field programmable gateway array. And this is your actual data plane CPU. And this particular data plane CPU, this Octeon chip, it is responsible for your data processing. And after that, we have here your management plane. So you will see your management plane is separate and your data plane is separate. All these components, they are a part of your data plane. And these are your interfaces. So Marvel chip, it has a connectivity with your Ethernet interfaces, and your Petra chip, it has a connectivity with your SFP plus ports. This is the architecture of your 5000 series box, guys. Okay. So this is how the architecture looks like. And if I'll go down somewhere, I have one more diagram, not here. I don't want to design it, otherwise it takes some time. This is the one of the diagram as well. You will see we have a management plane. It is having a multi-core CPU. Then we have a dedicated data plane, signature match processor, multi-core processor, and network processor, right? So we have this kind of architecture. Okay. Now coming back to your actual design. So let me just show you how these particular planes, they have a connectivity. Okay. So as we have seen, we have here interface stack, right? And these are all the Palo Alto interfaces I'm having. And I just have a, let's suppose I'm just having the Ethernet interfaces. So Ethernet 1 by 1, then 2, 3, 4, 5, 6, 7. Let's suppose I just have 8 interfaces. Now, these interfaces, they have a connectivity directly with one of the chip. That chip is known as a Marvel chip. And this is the dedicated chip basically, which is developed for Palo Alto firewalls. And who is the developer? Developer is Intel. Intel is the company who has developed this chip, but they have developed it for the Palo Alto firewalls only. And all these ports, these are the Ethernet ports. They have direct connectivity with this particular Marvel chip. Now, this chip further connected with one of the another chip. That chip is known as a network processor, or we can say this is your session offloader. Means if any session is offloaded by the Palo Alto data plane, that these kind of sessions is processed by the network processor. So here we have a 2 types of chip, Liger and high-end boxes, and we have a Tiger in Liger in low-end boxes and Tiger in high-end boxes, and they have a connectivity with each other. And they have these links is known as a joy links. These are the 10 Mbps kind of links, or we can say these are the very, very high speed fiber links. Now this chip further, it has a connectivity with one of the chip is known as a Octeon chip. It has a further connectivity like that. This Octeon chip is known as your DP CPU. data plane CPU. Now this particular CPU or this chip is responsible for your packet processing. Your packet, let's say your packet is received here, then this packet go to Marvel, then it will forward to Tiger or Liger chip, then this chip it will forward to your Octeon chip. Now this chip he will process the packet as per the life of a packet in PAN-OS. As per the Palo Alto packet flow, this chip he will basically do the processing. Now let's suppose this chip or this packet he also needs to send for the application identification and content inspection. That time we have another chip called as a Jaguar chip. So in high end boxes we have a Jaguar, in low end boxes we have a Ocelot. So these are the chip name, and this chip is only responsible for your app ID and your content ID. Now this is also FPGA, field programmable gateway array, and now your network processor is also a FPGA. So this is how your Palo Alto data path or data plane architecture is divided. And after that, we have here management plane. You can see this is your Palo Alto management plane. This is your management plane, and that plane it has a connectivity with your all these internal components. It is having connectivity with through the virtual links. So that's how your Palo Alto firewall management plane and data plane is segregated, and that's how they have a connectivity with each other. Now in your Jaguar chip, here we have a two types of algorithm, DHA and AHO, or we can say PS scan. DHA algorithm is responsible for your app ID. So if someone asks in PAN-OS which chip is basically do the app ID, so your answer is it is done by the signature match processor, where we have a Jaguar chip or the Ocelot chip, right? And which algorithm will take care? That algorithm is named as a DFA. And your AHO or PS scan, it is responsible for your content identification. That's how your data is basically processed by the Palo Alto firewall. Now, this is the architecture I'm having. If I'll just go here, now let me just write down few things. Let's suppose I have sent the packet from here, and it's a TCP SYN request. It's a TCP SYN request. So how my Palo Alto firewall he will process this SYN request? This packet reaches to the Marble chip, then your Tiger or Liger chip, then it will reach to your Octeon chip, right? Now this Octeon chip, it will start the processing. So what it will do according to the PAN-OS? So according to the packet flow of Palo Alto, it will process at the ingress stage. And after that, it will do the flow lookup into your session key, into your session table. Then what it will do? It will send that packet through the slow path. What are the checks that happen in slow path and all? We have already discussed in your packet flow, so I will not discuss that part. And after that, that packet go to your fast path and your forwarding stage, right? TCP SYN, it will not go to your Octeon chip because it is not having any kind of application data, right? Until now, session is created, and who will basically install that session? This session is installed at your Octeon chip, guys. Just remember. So your session table is a part of Octeon chip. Okay. And after that, that packet is exit out. Let's suppose it has just exit out from Ethernet 1x8 interface. This is how they will basically process your TCP SYN request. Now, We will get the reply from the server with sin plus x. So sin plus x reach to your marvel, then tiger liger, then oction. Now this oction chip here start processing. So TCP sin plus x, how it will do the processing? Ingress stage, then your flow lookup. But this time what happens, guys? It will found the flow, right? Session is already there. Let's suppose when we have processed the same, let's suppose one session ID is 100 is allocated, which means this time he will find out the session. So it will bypass your slow path and that packet directly go into your fast path. Okay, and after that your packet go towards your forwarding stage and it will exit out from the interface. So what he will do? That packet go like that. That's how they have processed the sin plus egg packet. And after that, we will get one more packet. That packet is egg packet, TCP, acknowledgement packet, right? How this firewall will process this egg packet? It will process according to this flow only. TCP egg is also processed according to this only. And after that, you will see, let's suppose we are accessing any kind of HTTPS website. What happens now? Now from this client machine, we will get client hello request. Now this client hello request reaches to the marvel. Let me use this color. This is the client hello, reaches to the marvel, then your tiger, then your oction chip. Now how oction will process the packet? This is the client hello request. Okay, so ingress stage, then your flow lookup, flow is already there. Then your fast path. Okay, and after first part, because this client hello, it is having some application data. So now this oction chip, what it will do, it will forward that data towards your Jaguar chip for application identification and for the content inspection. So that packet go to into this chip. This chip basically process that particular packet against your application signature database and all the content inspection database like your antivirus, anti-spyware, your URL filtering, all these things is deducted here, guys. All these kind of detection happens here or application identification happens here. Then your fourth thing, packet go towards the app ID, then content ID, and after that, that packet go to forwarding stage, right? So it will return back that packet with the results to Oction. Now Oction will basically forward that packet like this. So this is how your Palo Alto 5 do the processing. So guys, in this entire processing, you have seen my management plan is not coming in a picture. Then why we are here to discuss this management plane troubleshooting? Because traffic is not going through this management plane at all, right? Your configuration and everything is already there into your data plane, right? Your running configuration is already there in your data plane. Then why we have a management plane? Why we are here to discuss this management plane? So the thing is, guys, if I'll take an example of your VPN related stuff, or if I'll take example of your logs, we will generate this data plane, it will generate all the logs and it will forward that data here. Now, when this Oction chip, he is processing the packets, right? Who will control that process? Who is responsible for the packet processing? If I'll take example of all these packet is processed by the process name is Pentask. Pentask is the daemon in your data plane who is responsible for packet processing at your data plane. Now, who is the daemon who will basically control this pen task process, who will start this pen task process, right? So your management plane is responsible for all these management stuff. You will see your management plane has a connectivity with these virtual links through your Octeon chip or through your data plane CPU. So from here they will basically exchange some kind of control messages. Okay, they will exchange these control messages and they will communicate with each other. If we have done some kind of configuration changes and we do the commit, which means up that time what, when commit will complete, my management plane, it will load these changes into your Octeon chip. Whenever now we want to access this firewall, right, from the web UI or from the SHS, how we will access? We will access through the management plane only, because all these processes all these particular process of these web pages is running into your management plane only. That's why we are here to learn the management plane. Now, one more thing I want to cover here. So, as I have mentioned multiple times, your Palo Alto operating system, PAN-OS, it is a customized version of BSD Linux, right? What? It's a customized version of BSD Linux. And if someone have any knowledge of Linux environment, you will see in Linux, you will see multiple processes are running always, right? If you are using SHS, if you want to configure, then SSHD is a process or daemon who will basically take care of the SHS connection on your Linux environment. If you are running like Apache web services, then there is a HTTPD service who will take care of your HTTP related stuff on your Linux environment, right? So like, because Palo Alto operating system is also a customized version of Linux environment, what they have done, they have customized your BSD Linux, and on top of this BSD Linux, they have just add the PAN application, Palo Alto Networks application. And this entire thing is known as a PAN-OS. So guys, just remember, because your PAN-OS, it's a customized version of BSD Linux. That's why in Palo Alto Firewall, we have a process, or we can say we have a daemon, because Palo Alto management plane is a Linux environment. Palo Alto management plane is a Linux environment where several daemons are running. Where we have several daemons. If you will see, these are the daemon processes which are running. Even though if I run this command, so system resources. If you know this command, when you will run the top command on the Linux environment, you will get this output. These are the process, right? We have a pentast process, top process, right? Nnet, all these processes we are running. Nginx, pen DHA, right? All these processes we are, Nginx is running, SHS is running, right? Because I have logged in on this device via SHS, right? These are the two terminals I have opened. All these processes we are running, and you can run this command. So systems of test data, you will see all these processes here. So guys, because I am using here virtual machine or VM environment, all these kind of daemons you will see in my management plane only. But if you are working in a hardware platforms, you will see separate, you will see the daemons in your data plane, and you will see the daemons on your management plane. So we have a daemons, some which are running on MP, and we have a daemon, some which are running on DP. Okay. So these are the different daemons we are having. Okay, now let's come back to your whiteboard. So if you will see this architecture, now this is the actual architecture of your daemons. So in your Palo Alto firewall, let me just decrease the size a little bit to make some space. This is visible, guys, right? Can someone confirm on the chat, please? Oh, thank you. I got the confirmation. Thank you, guys. Okay, so if you will see, just remember, guys, whatever you have learned so far, maybe today you will see so many differences. In Palo Alto firewall, we have a data plane, we have a management plane, and in data plane, there is a one more plane is running, which is control plane. Okay, and in your data plane, we have a daemons like your master D core, sysd agent, tunnel D, your pan task, and pan task all packet process. Then we have a supervisor daemon, pan DH daemon, EH-mon daemon. Then in control plane, which is also part of your data plane, we are having a BRD agent, MP relay, and pancom. These are the daemons which we are having here. Apart from this, we have a management plane. In management plane, we are having the master D, controller or manager. This is the main daemon of your Palo Alto firewall. Master D, it's a father of all the daemons. Then we have a master D core. So this master D, one process is running into your data plane and one process is running into your management plane. Guys, do not turn on your camera, please. Yep, thank you. Okay. And after that, we have a lots of daemons here, and you will see almost all the daemons we are running in your management plane only. And now if we are running all these process in your management plane, which means definitely we will get some kind of load in your management plane, right? Because these process needs to work. If I take example, if you want to configure the high availability, then this agent, H agent, this is the daemon who will take care of all the H related tasks. And if when this particular H agent process, it will take care of all the H related tasks, which means it will need some kind of CPU and RAM from your management plane, right? To do all these tasks. So there are lots of chances you can get your management plane is also going high, right? If I'll take example of log receiver daemon, this is the daemon who is responsible for your traffic logs. Your data plane, in data plane logs has been generated and these logs will be forwarded to your log receiver daemon. Now this log receiver daemon will take care of all that thing, guys. What it will take care of? All of them. Okay, there is a one line is missing. So let me just put like that. Okay, so this is called logging and all. It's a part of management plane. If let's say your data plane is generating lots of logs, in that case maybe you will get your management plane is triggered, right? Such kind of issue you will get. So now let me just discuss, guys, these daemons one by one. Okay, and I will tell you the log file as well for each and every daemon. So I run this command again here, and if you will see, the first process which I want to discuss is your master D process or your master D daemon. And if you remember, or if you know, whenever we turn on your Palo Alto firewall first time, or when your firewall turn on first time, what it will do, it will first start your master daemon. This is the first daemon who will initialized first, or this is the process which is initialized first. And after that, this particular daemon, because he is a father of all the remaining other process, now this daemon will initialize all the other daemon process. So he is the father. So first daemon always is your master D, and one core of your master D is running in your management plane, So this will take care of your management plane related daemons. And one core is running in your data plane. So he will basically responsible for your data plane daemons initialization. So master D is first start running, and after that it will initialize the other remaining daemons process. Okay, so this is the main daemon we can say of your Palo Alto firewall. I have written here all the things. Manage all the other daemons. We can use this CLI to show all the daemon status. It is a father all the daemon. Apart from this, what it will do? It will also keep track of all the other daemon process. Which means what it will do? It will try to track all the other process. Let's suppose your firewall is running fine and there is a due to high load on one of the process, that process hanged, or that process terminated by the system, or it will just stopped. Now who will basically track all these activities? So this thing is tracked by the your master daemon. It communicate with all the other daemons by a system daemon. And it, in case of missed heartbeat, so what it will do, it will try to poll, it will send some heartbeat messages to all these services. And what it will do, it will try to get the details and will try to check the health of that process, it is running or not. Let's suppose that process is not running and he just missed the heartbeat. What it will do, it will restart that particular process, or it will restart this process. Let's take example here. If you will see, let's suppose your authority process is stop working due to any reason, due to some of the bug on the Palo Alto firewall, that process have stopped working. So your master D, what it will do, it will try to pull that service through the system daemon. And system, if you will see the system daemon, that daemon is a mother of all these particular process. This is a mother daemon. And you will see all daemons, they have a connectivity with your system daemon on port 28260. So what this master D, it will communicate via sysd with all the daemons, and it will basically keep track. It will restart them if required. Let's suppose there is a multiple services has been stopped due to any reason. What it will basically restart all these services. It will reset these services. Okay. So this is all about your master D. Now, if you want to verify the log file of this master D, you have to run this command less mplog master D dot log. This is the main file. Master D dot log. Just start it, and you will see here when your Palo Alto firewall started today. Or this is a very old log actually. It's a log of January month, not an issue. So that master D script log initialized, which means your master daemon is initialized. And after that, when this daemon is initialized, it has just started your system daemon. System daemon process is running with process ID, so it is keeping the track, right? Now what it has launched, all initialized this process, and it has initialized your sysd agent, DFA, management server, dev server, HA, SHSD, right, batch, all these daemons who is initializing now your master D, because we can see it is writing all the logs when he has started these services. See, if I'll do one thing, if I'll go down, or what I can do, the best way, let me just search the log by today date. Today is 23rd and month is 4. These are the today's log, right? And today I have started this firewall at 11:42, 38 seconds. And after that, you will see all these daemons has been started. Getting it, right? We are seeing all the details. It is keeping track of all these daemons, guys. See, all your services has been started, and who is responsible for all of them? Responsible daemon is your master D. This is the log file. If there is any issue, if you want to see your Palo Alto firewall, if he is not, Palo Alto is not starting properly, if there is any issue, we can always check that particular file. Is that particular service is started or not? It is initialized or not, right? That's how we will basically see the log file. After that, the second most important daemon is your system daemon. This is a mother of all the daemons, and you will see all your daemons like your, even though your master D, REST manager, BRD agent, HA agent, FF3, so many daemons we have, right? Depth server, user ID, management server, log receiver, SSL manager, Dagger, key manager. All these daemons, they have a connectivity with your system daemon on port number 28260. Now, let's take example, guys. In user ID, I have discussed, we can use global protect as a, or your captive portal, right? These things we can use as a source for user to IP mapping. Let's take example GP. So in case of GP, you have seen my firewall is maintaining the user to IP mapping, right? How it is we're able to do that? So whenever we will authenticate with the username and password, so your authority daemon will take care of that part, and this authority daemon will communicate through system daemon, and it will send that message to user ID daemon. I've authenticated this particular user. Here is the details. You can maintain your table or your user ID agent. It is also get the information from the RISE manager because it is responsible for your GP related logics and all, right? So they all communicate through your system daemon. All these daemons, if they wants to communicate with another daemon, either they can communicate directly. So like few daemons, like if I take example management server, it user ID directly communicate with management server. Your dev server communicate directly with your management server. Your log receiver will also communicate directly with your management server. But apart from this, let's suppose now if dev server wants to communicate with authority, what he will do? He needs to send his traffic through the system D. So system daemon what? It will manage your inter-daemon communication. Your inter-daemon communication is managed by your system daemon. So this is the log file we have seen. We can also run the grep command. So let me just copy this command directly. This is for management related things. Grep pattern initialization mp log master d.log. So what you have to do? So I think my pattern is not correct. Initialize, if I will copy this one. Then if I'll go with that pattern, you will see your master D is started or not. You will get the details here. But the best command is you can run tail follow yes, and after this search your logs on the basis of this time and date, and you will get your details. Okay. Now come back to your system daemon. It is the mother of all the daemons. It will manage inter-daemon communication. It communicate with other daemon on TCP port 28260. So which means all the daemons, they will communicate with sysd on port 28260. So if you go here in Windows, if I'll open my Windows machine here, command prompt, if I want to see the connection, I used to run this called netstat -n. It's netstat -n. We used to run this command to see what kind of connection is established and all, right? Same thing in your Palo Alto firewall, you have to run this command show netstat run this all command. Yes. What it will give you, you will get all the details. All the connection details you will able to see here. Just wait, it is taking some time to show you the results. So meanwhile, let me also start that connection, because when you run this console netstat all, you will not get the results very fast in VM environment, because you know VM are the slow, even though you will get some error, right? Error in executing netstat command. Run it one more time. In production devices, when you will run that command, you will get the result right away. Just give me 1 second. Again, we have get the error. So this is in VM environment, guys. Okay, so don't worry. So what we used to run, we used to run this command like that always. Netstat numeric, yes, hit enter. And you will see all the connections here. You will see there's a lots of connection on port 28260. So many connection is established, right? If you will run this command like that, match, so you will see all the connection with your sysd. You will see lots of connection is there with your system daemon. All are TCP connections. Some are in established state, some are in time bit, right? So because all your daemon, they will communicate with your system daemon on port 28260, and we can see that connections is there, right? The one connection or TCP connections is there. So we can see here all the connections. If there is any problem, actually this command I am not able to run it properly. Statics, yes, you can also run the statics and all. You will get some more details. 8 embeds and cookies received, right? So you can also check the details if you want. Then we have some other things here. Interface, if you want to see the interface related info, hit enter. You will get the details. These are your interface counters and everything. Now, if you will run this listening, hit enter. That's the problem. Actually, these commands is taking lots of time. It's a VM, not an issue. Let me also do one thing. Let me also start this firewall here from my EVNG. But the best command, we always run this netstat numeric, yes. And if you enter like that, you will see all the connections. If you want to check, see, you're getting everything connection connected and all, right? Let's suppose right now I have login with on SHS, right? So if I run here 22, you will see these are the connection with port 22 from on this IP address, right? This is the IP address of my machine. So whatever connection is established, you will get all these details here. You have to run this command, even though I have here web UI open, right? That's why you will see I'm having here connection on port number 443. All right, now see my Palo Alto, he's also making some connection with these portals for downloading some information. right? So you will get all the details like that only. If I'll refresh it here, I'll go here. If I run only match 443, you will get all the connection with 443. So if someone is asking, his connection is not how many basically users is connected or how many session is open for this firewall, you can run this command and you can able to tell them these many session has been initialized on this firewall management interface. They are the people who is accessing this firewall. You will see multiple connection on port number 443 from my main machine. Okay, cool. So if you want to see the log of your system daemon, run this command less mplog sysd.log. This is the log file of your system daemon. And here you will see all the logs related to this particular daemon. If you want, you can also filter it out, all these logs. You will get all the logs here. Because your system daemon is the main daemon. All the other daemons, they will communicate through your system daemon. Even though when we configure the HA, and that part we have already seen, right? If you configure the HA, right, in your Palo Alto firewall, between firewall 1 and firewall 2. So this is your firewall 1 and this is your firewall 2. In this firewall, let's suppose this is your management plane of firewall. This is the management plane of Palo Alto firewall. Then you have seen we are having an HA1 interface. HA1 interface here as well, right? On the Palo, both the firewalls. Let's say this is the interface. And in management plane, you know, we have a system daemon, and on top of we are having your H agent daemon also. H agent daemon here in this firewall, and we have here system daemon. Now you have seen from Palo Alto firewall 1, system daemon, it will communicate with system daemon, right? Your HA agent, it will communicate with HA agent through your HA1 interface. This thing we have already seen, right? There is a TCP connection has been established, right? Because these firewall 1 and firewall 2, they need to sync some configuration and everything, right? That's why their HA agent, they will communicate each other through the system daemon in that particular case. Just remember that part. Okay. I have already discussed this in your HA class, so not an issue. Come back here. So this is your system daemon, guys. And this is the log file of your system daemon. If you want, you can filter the log for today. Time is 23rd. Month is 4. So these are the system daemon related logs. You will get all these logs details here. Okay. So this is your system daemon. Now let's go here and let's discuss the next most important daemon is, I just remember this port number they will ask in the interviews. System daemon runs on which port number? So you have to tell 28260. So net state numeric yes, pipe match 28260, you will able to see all the connection on this particular daemon. After that, the most important daemon is your management server. Now this management server daemon, it is have a connection with your system daemon on port number 28260. But this management server also have a connectivity with your dev server, with your user ID, with your log receiver. And they all communicate with management server on port number 10,000. It's a TCP port 10,000. Now What is the job of this particular daemon? Your management server, what it will do? So it manages backend task. It take cares of your commit, or it will take care of your configuration management. So guys, whenever we do any kind of wrong configuration and all, that time you will see validation happens, config validation is done. Who is responsible for doing this thing? This is the daemon, your management server. This daemon basically do the config validation, and this is the daemon who is also responsible for managing your candidate config file. It will also take care of your commit process. It is also responsible for your reporting, and it is also take care of your some part of your web login. Not everything, but it will also take care of some part of your web login. Whenever we will access firewall by using graphical user interface, this is the daemon who is also responsible for your web UI login. But the main daemon for web UI login is your HTTPD. This is the daemon who is basically responsible for web login. Not an issue. I will come on this daemon later. It communicates with other daemons on port number 10,000. Now, if you want to see the log file of this daemon, how you can check? Go here. You run this command less mplog ms.log management server.log, which is ms.log, and this is the file of this particular daemon. You will see the logs here, and right now you will get by default the logging level on this daemon is informational. So if you want to enable the daemon, if you want to enable the log, you have to run this command debug management server, and if you run this command, you will get multiple options in your management daemon here. If you will run this command connection, here you will get how many connection is there, and you will see all this connection port 10,000. All your daemon, they will like your user ID, it's communicate on port 10,000. Distribution, then IoT, local host dot local domain, right? You will get all the details here. Request out, response out, request and response in, create time, socket is this. You will get all the details, in message, out message, right? So you can also run this command to check there is a proper connection. Now, just remember one thing, guys. Let's suppose your Palo Alto firewall. Palo Alto firewall, it is you are just managing this firewall with Panorama. Then in Panorama also we have the same daemon, guys, mgmt or management server. This daemon we are also running in this particular Panorama, and this firewall here also we are running the same daemon, mgmt server. So both daemons, this and this, they will basically communicate with each other. What they will do, they use to communicate with each other. And when this Panorama, he will post the configuration on this Palo Alto firewall, then this is the daemon who will basically take care of that particular configuration. And one more thing you have to remember, Palo Alto firewall and your Panorama, they will also establish the connection with each other. You will see this is the daemon where you can able to see that particular connection is established. Okay, so this daemon is also responsible for doing so many things. So what I can do, Let me go here. Let me run this on debug management server on. And guys, these are the debugs level on Palo Alto firewall we are having. We have a warning, only output, error, and warning kind of logs you will get. We have an info. So if you enable the debug at the info level, that time you will see only the error logs, warning logs, and info logs. So this is the lowest level of debug, which is error logs. Then we have a warning. Then we have an info. And you will see most of the daemons, they are running with the info debug mode. And after that, we are having debug, then dump. Dump is the advanced debug level. Here you will see everything. And this debug, generally we will run at the debug level as well for doing the troubleshooting. So let me run at the debug level. I'm running at the debug level. Let me just run here tail follow yes mplog ms.log. So now I am basically, I will run this con tail follow yes mplog, then that particular log file. So I will get the live logs now. What I will get the live logs, guys. Now let's do one thing. Go here. Let's log in on the firewall. I have logged into this firewall. You will see I'm getting the logs here. So this is the daemon who is responsible for all these things, right? When we log in on the firewall, some part of this login and all, it is handled by this daemon. You will get the details here. Right? Okay. This is the first part of it. If you have a login problems and all, you can also check the logs here. And there's a one more daemon who is also responsible for all of them. Less mp log, or that daemon I will come later maybe. Yeah. devsrvr.log. I'll come on that daemon later. Okay. Not an issue. Now let me just do one thing. Let's go here. Let's make some changes and let's do the commit. Let me just add one object here. Add this object. And let me just delete this object. These are the test objects. Let me just delete them. Let me just add one more like tsuit. This is the test object which I have added here. Added. Now let me just do the commit. Commit is going on. Now you will see the log is written into this daemon. This is your commit related logs, guys. So this is the daemon who will take care of your commit related process, and we are getting the log files here, right? And if your commit has been succeeded and all, you will get the details. So not an issue. Let's see, it is checking this commit with against all the daemons. It is validating the configuration of commit. So you will see phase 1 is completed for your commit, because commit having 3 phases: phase 0, phase 1, and phase 2. Phase 1 has been completed. Now you will see it has entered into your phase 2. And after some time you will see this started. It is about to complete. Let's wait for this process to complete. You are getting the logs. So now if you are facing commit related, commit is not happening, what you will do? You will verify the logs of your management server daemon, because right now I have enabled the debug. So that's why you are getting here lots of daemons, right? You will see this is the configuration which I have done, or this is the network objects I'm having, right? Total count is 16. You will get all these details. Now, this is the config devices, entries, host name, all these details, right? Even though if I'll go on top, you will see the configuration and other things here. IP address of my Palo Alto firewall, all these things you are seeing here. And if I'll show you the commit related stuff, so you will see you are getting all the information right here. Now, if I'll go on top, because we have a lots of logs here, just go on top here. See, commit, he's basically checking for commit and all, right? He's validating the things. This is the basically encryption algos and all ciphertext related info here. Device reported phase 2 was successful. So if your commit is successful, so the phase 2 means commit has been successful. These are the logs here. It is basically checking your configuration for route against your route the daemon, who is your routing related daemon, then HA agent, then IKE manager. This is for BPN, log receiver, DSCPD, word receiver, user IDs, satellite ID, SSL MGR, triple POED, DNS proxy, crypto D, L2 control, right? It is checking against all these daemons, REST manager, auth SSL BPN, and all these daemons they have reported. Yeah, configuration is fine. And you will see from phase 1 also it has done all the checks. So if you are facing the commit related problems, how you will troubleshoot, we will always check the log file of this daemon. If there is any issue, you will get these details here. And generally, just remember, guys, your commit process, either it will fail in phase 0 or either it will fail in phase 1. Commit is never designed to fail in phase 2. If your phase 1 is passed, which means in phase 2 your commit process will not fail. Just remember. And you will see all the details here. Okay, so guys, now you have seen here, I have enabled the logging level at debug level, right? But now how we can disable this thing? So you have to run the simple command, debug on, and set back to the info. But let's suppose you have forget what was the initial level of that particular daemon. What is the logging level initially with that daemon? So you have to run this command. So or debug software, and after that you have to run, there's a one command, debug system, debug software. Then we have the command, actually command is not on my mind right now, not resources. So software, so system software status. So this command will tell you the process and all related information. Let me just see. This is for services and all. It will tell you what are the service we have enabled on management plane. Command start with the debug only, debug system debug software. Not that one. Not an issue. That command is not on top of my head right now. There is a one command which we generally use to basically check the logging level. Not an issue. If I remember, I will run that particular command. Okay. Now, so we have seen your management server daemon. What it will do? It is responsible for command related process, your configuration management related stuff. And if you are doing reporting, if you are generating any kind of report, this is the daemon who will basically take care of that part. Your web UI login, right? When we have logged in, we have seen some logs. This is the daemon who will also take care of that part. And it will communicate on port number 10,000. So this is the third most important daemon of your Palo Alto firewall. Now, common issue you will face when you will try to push the configuration from Panorama on your Palo Alto firewalls, right? You will see maybe your Palo Alto firewall management plane is went very high, or maybe you will see your Panorama management plane is going very high, or maybe you will see this commit is failed. It is not pushing the configuration properly. It is taking so much time. In that scenario, what we have to check the status of your management plane or management server daemon. Sometime in Panorama, we have to restart this particular daemon. If you want to restart this daemon, what is the command? Command is very simple. Debug software. Restart, use process. Then you will see all these process you can able to restart AuthD, CryptoD, CTD engine, device manager, right? And you will see here your management server. You can able to restart this process. This is the just simple command, but this restart is a last resort, guys. This restart is a last resort. Okay, we never restart until it required in the customer environment. Just remember. And after that we can run through it, so it will basically restart this process. But I will not restart this firewall. I will do, let me just go here because I do have one more firewall on my EVNG. Let me just log in into this device. So it is having IP address 192.168.137.10. Just wait here. So I will restart here. Okay. Command is debug software, restart, process, management server, and do go here and just run one command here, tail follow yes ms, or just run this command master mplog master d.log. Because if we will restart any process, you will see one login table will be generated here. Yes, let's do it. It is starting. Process management server was restarted by the admin. You will see management server received a user restart request. User restart user triggered by a CLI, and management server received user stop, right? We are getting the logs here. We have got the log on your management server. If this time, if you run this command, so software or debug software, so okay, think I have lose the connection as well, because this daemon, it will also take care of some of these activities. Okay, see, system is in initialization state right now. You will see the details because we have just started the management server daemon process. Okay, so that's why that kind of things you will see. And if you want to read right after that, what you can do, you can read the log file of that daemon. Okay, debug software. I got the command, guys. This is the command logging level. Press the question mark, show level service, then all services. So this command will tell you what are the default logging level on all the daemons. Right now you will see on H agent level is debug, authority level is debug, right? You will see these things here. Let me just change the debug level. Let's suppose I want to change the debug level on management server as dump. If you run this command, you will get management server running as a dump level. And let's say you have done lots of troubleshooting and you forget what are the daemons you have used, what are the commands you have used, you have changed the logging level on multiple daemons. What you have to do, you have to run this command set level default services all service. So what it will do, it will set the default debug level what was there as per the PAN-OS configuration. So that's how, guys, we will do the troubleshooting of your management server daemon process. And after that, the most important daemon is your dev server. What it will do, what this dev server will do, so by default all daemons configure with the default logging level. If you want, you can run this command if you want to change the logging level here. Okay, you can change by using this command, change the debug level. Now dev server, dev server stands for device server. What it will do, it take care of pushing the configuration to DP. This is the daemon who will basically push the configuration to your data plane. It will push the configuration to your data plane. It communicate directly with PANCOM. It will also communicate with your PANCOM daemon for URL filtering, request and response. So which daemon will take care of your URL request and response thing? You know, in URL filtering, let's suppose my Palo Alto firewall. It is not having the URL details into DP URL cache and your management plane URL cache. Then what we have to do that time? We have to do the lookup on CloudDB. So this dev server, what it will do? This is the daemon who is responsible for, it will communicate with PANCOM. And now PANCOM will take care of your URL request and response. But apart from this, what this dev server will also do? It will also responsible for the or for making the connection with your PANDB URL cloud. It is responsible for, so as I have mentioned, your URL filtering solution of Palo Alto, which is PANDB cloud. It is hosted on AWS into 5 regions, right? Region is, first one is your North Virginia, then we have a California, then we have a Singapore, we have a Japan, and one more region is there, I forget the name. There's a five reason we have for URL filtering, right? Now, let's suppose I'm in India, right? Now I want to establish the connection with the best available URL filtering database or URL filtering cloud. So I can query that particular cloud for getting the category of the URLs, right? So I will do the cloud election process. What I will do, I will do the cloud election process. Now, which daemon is responsible for this election process? Your dev server. Your device server is responsible for that part. Okay. Now go back. So there is a one line is missing, guys. Your device server, it has a connectivity directly with your pancom daemon. They have a connectivity like that with each other. Now, so this is the job of your device server. It will push the configuration to your management plane, sorry, data plane from your management plane. It is responsible for URL request and response. It will communicate with pancom directly, right? So if I run this command here, less mplog dev server.log, this is the log file of that particular daemon. If I'll open this log file, if I'll go down, you will get all the details here of this particular daemon. So let me just show you the cloud election process kind of stuffs here. So how I can do that? The best way to do a search on this daemon for the URL related logs. Let me just go like that first. So you can basically check this log file entirely. You can run through what are the things we are having into this particular daemon and all, right? But what I used to run the command with the grep option here. Grep pattern URL, capital URL, then I have cloud. mplog devservr.log. Now you will see these logs I have already covered in your classes, right? But let me just give you the glimpse of it. It is trying to communicate this server list URL cloud paloaltonetworks.com, right? PanDB cloud list downloaded successfully. So it is also responsible for downloading the initial seed. It will make the connection. See, election process had been started, and this is the server which is elected. Yes, right, was elected. So this is the daemon who is responsible for your cloud election process. You will get all the logs here related to the cloud election process. Apart from this, just wait here. Apart from this, if I run this command tail follow, yes, mplog devservr.log. Okay, now if I'll go here, if I run one command debug, or let me just run the basic one test URL. Let me just test the URL info with the cloud. For a URL, let me just put here one URL which is amazon.in. I want to get the query. I want to get the URL details of this particular Amazon.in. You will see I get Amazon.in belongs to the shopping category, but I will also see I just test the result for a site. So this is the daemon who is responsible for your request and all. We have just generated a test site results, right? So this is the daemon who is responsible for that part as well. Apart from this, if I run this command debug device server, you can also able to run the debug. If you will run here pan URL DB, what you want, if you will try to send the real action process for URL cloud, if you run this command, you will see lots of logs after that here. See, now it is trying to download the list of all the cloud, and this list is inbuilt. See, this is the URL cloud election process. So which daemon is take care of that part? Your dev server. Dev server is a daemon who is responsible for doing all these things, and we can able to see the log files here. So this is the daemon who is responsible for all of them. So just remember that part, guys. Now, just wait here. So URL cloud status. Yeah, status is connected. So everything is fine now. It is compatible. Now I will again run the same command. And now let me do one thing, because this daemon is also responsible for loading the configuration on DP, right? So if I'll go here, let me just delete these test objects. I've done some changes. Let me do the commit. And when I will do the commit, which means now I have my management plane, it will load that particular changes into your DP, right? And you will see some logs here. So that's how basically we will do the verification. Just remember. And if you know the correct daemon file, you will see config commit phase 1 started, updated the phase 1 count to 3. No need to sync the base IDs in config. Config commit phase 0 done. Then phase 2 has been phase 1 is started. Not device server, not only content and all. And you will see so many logs. Why we are getting these logs? Now what it is doing, it is trying to load the configuration into your pen commit is pen config commit is called. You will get all the details. Config is committed successfully. Setting the categories from config start distract to stbd, right? You will see all the logs here. User had deleted some configuration. No need to sync user IDs, right? So you will get all the logs here. So which daemon is responsible for loading that config on MP? Your dev server. Dev server is a daemon who is responsible for loading all these stuffs. And right now it is just generating the basic logs. If you want, you can also generate the advanced logs if you want. No change in config detection, right? Change is not detected. We have just deleted. So what it will do, fetch the config journal, disable EDL logging, no matches, right? So this daemon, it will check all these stuffs. This is the certificate details and all, global protect and everything. Pen config parser has been started, right? So we will basically always check the log 5 of that particular daemon. Okay, now go back and let me just close this lab. Yeah, one firewall is running. Let me stop this device. And I will come back into this lab again. Let me just close this lab. Let me open my GP lab here. Let me start this machine. So now I want to show you some kind of log like user ID related logs, right? So now the another daemon which we have here, which is your user ID. So what did this daemon will do? User ID. So as name suggests, it is responsible for IP to user mapping. It do all the user ID related functions such as communication with the user ID agents. So let's suppose we have a PanOS inbuilt user ID agent, right? Or if let's say we are having some external user ID agent, what it will do, it will communicate with these particular agents. It will also able to communicate with syslog, XML API, GP, PanOS, user ID agent, LDAP, and it communicate directly with the PanCom server and your management server. So it will also communicate directly with your PanCom and your management server. But it will communicate directly with your management server and your PanCom server. Right? It also communicate with sysd for communicating with other daemons. It also update the user to IP cache. So which daemon is responsible for managing user to IP cache? Your user ID daemon is responsible for all these steps. If you want to see the log file of user to IT daemon, you can run this command. Less mplog user idd.log file. This is the log file, and in this log file you will see everything. NTLM connection, all the details you will see. You will get all the details of that particular daemon. Because what it will maintain the user to IP mapping. And if you run this command, so user IP user mapping all, this is the daemon who is basically responsible for that part. If you want to run the debug on this daemon, run this command debug user ID. You can run the debug on at the level which is debug. If you run this command, if you want to see the live logs, run this command tail follow yes mplog user id.log. This is the log file of that daemon, right? Now what I have started my evng here, I have started this machine. So what I can do, let me log in, because I have configured the global protect on this machine. So let me log in as Hemu here. If I can able to do that, otherwise I will log in as an admin account or as an administrator. The GP config is already there on my device, so we will check the logs after that. Or let me also start my Windows server. So we will see some logs. GP configuration is already there. We have authentication, so I'm using localauth here, and the portal I think I'm using the Okta. On portal, yeah, I'm using Okta, so at least I can see something. Okay, now let me just start this machine. So I'll just open here. GP is already started. You have seen here, guys, right? Because when I have turned on this machine, GP is started and it is trying to connect with Okta. You can see the things here. Global protect login.esp, and this is the Okta page we are getting. Let me put the username Hemu at sianets.com. Password is, so let me put the password. I think I'm putting the correct password. I will get the notification on my phone now. So let me just get the push notification. So I'll got the notification and let me press here 52. I got the access. So I have authenticated myself with the portal. And now you will see I also need to authenticate myself with the gateway. And meanwhile, you will see the details here. AD group has connected, right? All this info you are seeing, and you can also get so user IP user mapping all. We don't have any mapping for now. Let's wait here for some time for the proper connection. These machines is very slow. So we have to wait for some time. But this is the main daemon here, and you will get all the logs. So we'll take care of your user to IP mapping. We have connected with the Active Directory, right, on this port, so we can see all the details here. And after some time, definitely you will get the user to IP mapping. See, I'm getting one of the mapping, right? And all this thing is done by this daemon only. User IP user mapping, right? GP user password is admin at 123. Because I have used different authentication method on gateway, different authentication method on portal. So that's why portal I'm using Okta. For gateway I'm using normal local database. When I got the connection successfully, you will see connected. Now you will see the logs here. Pan hip report init.xml. Pan distributes a relay agent, right? Copy all these messages and you will see all the logs here. And if you go here this time, if you run this command, you will see the mapping. We have one of the mapping for GP user, right? User ID agent is user ID. You will get all that. User ID config agent received a command from the server. So this is the daemon who will basically take care of all these steps. Okay. If I'll do one thing, if I'll go here, if I'll disable the connection, if you go here, if you run this command, this cache has been removed. And you will see received a signal to execute the user ID agent. And this is the information. They have basically removed that particular details. So that's how generally they will basically, or that particular daemon, it will maintain your user to IP mapping. This is your user ID daemon. If you are having any issues, we have to check this particular daemon. We always check this particular daemon for the troubleshooting of your user related stuff. If you want, you can also restart this daemon. You can have to run this command debug software, restart, process, then user ID. And what it will do, it will restart your daemon, which is user ID daemon. I don't want to restart on here, but I will restart into my left firewall. So what happening with this device? It's easy. You can run this command. Why I don't want to restart. Otherwise, it will restart the lots of things. Okay, so I don't want to restart. But if you want, you can basically try that part at your environment. Okay. So that lab firewall is down because we have exit from that VPN lab. Okay. Now go back to into this diagram. And after that, we have the one more daemon is known as a dagger. This particular daemon, this daemon, it has a direct connection with your system daemon. Now, what is the use of this dagger daemon? What it will do? So this dagger daemon, generally, whenever we will log in into our firewall, right now I have logged in into my firewall via SSH by using the management interface of my Palo Alto firewall, which means I have logged in into my management plane. Now, if I want to fetch any information from the data plane, which means I have to query to my data plane, right, for the information. Which daemon will take care of that part? This dagger daemon will take care of that part. It is responsible for operational commands from your management plane to data plane. It will send these kind of commands to your data plane from your management plane. It is responsible for operational command which we runs from management to data plane, then Dagger query the DP for the information. If you will run this command, less so running resource monitor. This is the command of your management plane. This is the log file of your Dagger daemon, dagger.log. So if I'll go here, if I run this command, tail follow yes mplog dagger.log, right? And if I'll go here, if I run this command, which means I'm just fetching the information from my management plane into another window. So I have fetched the details, and you will see operational command is sent to the data plane for the resources. We are fetching the resources. And we are getting the resource here, not an issue. We will discuss this command output. If I running this command, so running rule base, or let me just see the hit count. For rule base, security rules, rule name, or let me just see the all rules. So virtual system I don't have. So running security policy. This is the security policy. I have basically fed that detail from the data plane, and you will see Dagger has sent this particular command, op command for compat. So this is the daemon. So sometimes if you are fetching the details from your data plane and you are not getting that info from data plane, there is some issue. What you have to check the log file of your Dagger daemon. Less mplog dagger.log. We will check the log file of that daemon. You can just filter out logs on this update. 04 minus 23rd. And you will see all these things here. We have run lots of netstat commands, right? And we have not get the results. We'll see all the things here. So this is the Dagger daemon who is responsible for all of them. Now, so software, system software status. We used to run this command, right? To see the software details and all. And you will somewhere see your Dagger daemon running. So all these daemons, they are running here. And if you can also use this command match Dagger. So Dagger process is running and this is the process ID. Okay. Now let's move towards the another daemon, which is your H agent. This particular daemon. So what is the job of this daemon? What it will take care? It will take care of your HA related task. High availability related task is taken care by the HA agent daemon. This daemon information we have already covered in your high availability T-suite classes, guys. How we can what are the messages we can verify, but today I'll just give you the glimpse of it. So what it will do, it will manage your HA status and state. It will manage your configuration sync between your peers. Log file is hagent.log inside your management. And this command we will see if you want to. And this command we will run tail follow yes if you want to see the live logs. On this firewall, I have not configured HA tail less mplog HA agent.log. And this is the log file. Starting your HA agent and all, you will get the details. All these logs are there. So if there is any issue with your high availability, always check this particular log file. Troubleshooting part we have already seen on your HA classes. So, but I just give you, this is the daemon who will take care of your HA related stuff for control link or for your HA one link. Your config sync is done by this particular agent process only. And that process is also responsible for maintaining the session details. Okay, just guys give me 1 second. Okay. So this is the HA agent daemon. Now let's go here and let's discuss what is AppWeb3 daemon. So in AppWeb3 basically it's not a daemon. It's just a process or it's just a web server. We can say in Palo Alto terminology, this is known as a like PHP layer. Or we can say it's just a web server which is running your PHP on PHP. This AppWeb3, it is having 3 processes. You will see here AppWeb3 is the main process which is having your web server, SSL VPN and L3 SBC. So these are the 3 services it is also having. Now this AppWeb3, what are the jobs of this daemon? So in AppWeb3, if we have a like SSL VPN service, which is this one, SSL VPN service, what it will do? It will responsible for serving the web pages for your global protect. So your global protect related web pages is served by the SSL VPN service. Then we have a AppWeb3 L3 service. This particular service is responsible for your captive portal page. You have seen whenever we are trying to access any website over HTTP or over HTTPS, and if you have configured the captive portal, we will get the login form, right? And this particular L3 service is responsible for presenting that particular login form. It is also responsible for sending the response pages and blog pages. You have seen if we have any kind of, if we are having a block rule for any kind of malware or if we have a block rule for your antivirus, your anti-spywares, for your URL filterings and all, right? We used to get the response pages from Palo Alto Firewall. We will get the block page for URL block, URL override page, app ID block page, antivirus block page, vulnerability block page, file policy override and block page. All these block pages, who will serve? You will see all these requests is taken care by the L3 SBC service. This is a layer 3 service. Apart from this, I just want to add one more point here. It is also responsible for your clientless VPN pages. Then we have a Web3 web server. It serves the web pages for web UI. So whenever we will access the web pages, this web server daemon or process will take care of all of them. Nowadays, in your PANOS 10, there is a one service which is HTTPD. It is responsible for serving the web pages, but web 3 was the process. In old days, this is the process who will take care of your web pages and also web 3 is responsible for all these three activities. Now let's see the SSL VPN related log first. So you can either run the command like this, less web 3 log, then you can run here SSL VPN access.log. And you will able to see the VPN related logs. But what I want to run this command like that. Tail follow yes mplog web3, not this one, not like that. Log, then SSL VPN access.log. I can run this command, and there is a one more log file is created for web3, which is less tail follow yes mplog web3.log. web3 SSL VPN.log. Just run these two commands. Now go into this machine. Log in here. Admin add 123, hit enter. I'll go here. Let me increase the size of this machine. Start without data. Now let's go here. Open this VPN, just enable it. Now you will enable, and if you go here, you are seeing some logs here. Global protect pre-login.tsp. So first request coming to your pre-login.tsp, right? If I'll put the password here. If I select the push notification, 14. So let me press here 14. Now I have to log in with the local database, which is GP user, and password is admin@123 for this one. Now you will see all your global protect like pre-login.tsp, then your getconfig.tsp on your global protect directory, then you in your gateway directory like pre-login.tsp, login.tsp, right? Getconfig.tsp, then SSL connect, SSL tunnel connect.ssl VPN, all these requests is served by this particular process. So this is the daemon, or this is the process basically who will serve your web pages. If you will see the log file here, you will not get the logs in much details here. So if you want to see the log in detail, can run this command tail or debug global protect on, hit enter, debug SSL VPN global on at debug level. We have enabled the logging at the debug level. Now, if you go here, if just you do one thing, refresh the connection. It is trying to establish the connection. Now you will get the logs in much details. See this kind of request and all these pages. Who is serving? Your app Web3 service is serving. We are getting the details here, right? We have to log in because I have configured every time I have to log in. Come on. That is the problem with the BMs actually. Always you will get some slowness and all. Click on verify. Push notification. Now you will get the push notification. 43. Press the 43. Done. Now you will see all these logs you are able to see here, right? So this is the process who is responsible for all of them. Username is this, right? Auth request, everything is there. And here also you will see the process. So this is the daemon who will take care of that part, guys. Just remember. Now, apart from this, as you have seen, if I'll go into my object, if I'll check my URL filtering object for URL filtering, let me just check what is the website I have here with the block action. Social networking is in blocked action, right? So if you want to see, if I'll go into my machine here, let me just log in here to this local machine. Meanwhile, if I run the log here, tail, follow, yes, web server. If you want to see the L3 service log, this is the log file, L3 SBC access.log. And you will see here your response URL block page and everything. It is served by this particular daemon only. Just remember, your captive portal related page is served by this daemon. So if you are not getting captive portals and all, you have to check this particular daemon file. You have to check this daemon file always. Let me log in on this machine and we just do the small test. I'll open this browser and I will try to access facebook.com. Yeah, I'm getting the page. Twitter.com. Yeah, Twitter is blocked. And you will see the log file for Twitter. Even though LinkedIn.com, it is blocked. URL admin page, we are getting these pages and all, right? So this is the daemon who is responsible for all these activities. In this machine, if I'll go here, if I'll open in the private window, if I'll type here twitter.com, because sometime we will get the details from the log. So this is the blog page we are getting. Okay. So what I think, this blog page is not served by this service. This service is basically serves the when you will get the blog page that continue and override kind of page. Okay, so I have to find out one of the website where we have set the action override. So let me see the shopping. So if you check alcohol and tobacco, content delivery networks, cryptocurrency is continue, hunting and fishing. News, with the news we have a override action, right? Okay, so let me just try to access the website, which is cnn.com. I'm getting this page here. Add exception, confirm. I'm getting the continue, and you will see this page is served by this particular daemon for cnn.com, right? So this L3 service is responsible for all these stuffs, guys. Just remember. Okay. So it serves the captive portal page. It will not serve your response page. Sorry about that. It serves your blog page for URL block, URL override page. It will also not search the URL block page. It will serve URL override page, not app ID block page, neither, not these ones. Okay. Override page it will serve, but block page it is not serving. Yeah. Now we are good. Okay. So what we can check the log files here. This is how we will generally check the log files. There's one more log file is there. If you run here web access.log, generally you don't have a permission to read this particular file. Less mplog, no. And if you will try to type here httpd, you will not get any logs here. Web server also. So generally all the web server related logs you will see here only. Okay. And if you press the question mark, these are the multiple options which we are having here. In web3, we don't have much information. These are the only two files we are having with regards to the SSL VPN. Okay, so this is how your app web3 service it will helps. Now, the next daemon is log receiver. What it will do? This daemon is responsible for recording the traffic logs, and it will send these logs to the data plane. It is responsible for recording the traffic logs sent by the data plane. So generally your data plane, it will process all the packets. So it will record these logs and it will send these particular logs to your log receiver daemon. And it will communicate with other daemons via systemd, and it communicate with management server on port 1000. All kind of log processes handled by the log receiver daemon. So this is the daemon who will basically responsible for your log related activities. You can run this command like less mplog, and you will get here log receiver.log. This is the daemon who is responsible for all these activities. And if your logging is not happening, you can check this particular daemon file. So this is the file which we will generally verify if we are not getting any logs. 202204 and today days is 23. These are the logs which is generated for today. See, log receiver start. It has started. Sysd worker and all, and you will get the details with regards to the logging. Debug. You can run this command -log receiver, and you can enable to. You can run these many commands with the log receiver daemon on, and you can run debug, dump, normal, whatever you want. So if you will run, so it will tell you the default debug level. These are some other commands you have here. We always check the statics. So it will tell you how many, what is the incoming log rates, what is the writing log rates, what is the corrupted packets and everything, right? Traffic logs written. So you will get all these information here. Then you can also able to run the command which is container page and all. If you want, you can run this command, but not required. And if you press the question mark again, we will also run this command log receiver, or we will run here log db uses. It will tell you the how many that particular database has been used by the logs here. So alarm logs is 20k, index is 20k. And after that, when this quota or these logs capacity reached maximum, it will start purging the old logs. It will start deleting the old logs. So you can also able to check by running this particular command. Debug log db uses. Debug log view. You can run this command. Debug log view. So it will basically fetch lots of information. So it will always take some time. But this particular daemon is responsible for your logging related activities. You can also run this command show logging status. So this is the output of debug log view. You will get all the details. Lots of details are there, not useful, some are useful. So logging status. So it will tell you the log related status if you are forwarding any logs to the log servers. In my case, I am not forwarding anywhere, so I am not having anything here. Okay, now we have a syslog ng. It is responsible for log forwarding to syslog server. So this is your syslog ng. What this daemon will do? It is responsible for your syslog related activities. So you will get this daemon details somewhere here. I have written it. That daemon is also running in your management plane, guys. Just remember, it's a sysd daemon. So where I have put that daemon detail, Dagger,